Okay, so some of us, I want to thank everyone in the room who's on task and has their binders open. Those that don't have their binders open, please consider this a warning. All right. I'm not coming for you, I'm just telling you. You should have your binder open. Can you do what now? Today's September 16th. And tomorrow, it's Monday, obviously, and tomorrow I'll have a 3-week agenda for you, 3-week syllabus on what we have to cover, including chapters, assignments, homeworks, and classwork and labs. So they'll all be listed, okay? I'm going to focus on that fourth period instead of grading today. So if there's anything that's in there that's not graded, it's not going to get graded today. Someone want to call the nurse. I think someone's having a seizure.
Shreya, what? Oh!
Give me the music, whatever is in your ear.
There's nothing in my ear.
You said music's in your brain? All right, I'm not cutting this out. This is going up to your parent. Y'all, they have to know what this child is doing in class. Sharpening her pencil, dancing, and singing. It sounded like there was music in her ear, but I guess it's all coming out of her head. I have no idea. All right, so let's move on. So a long time ago, I don't know if you've ever watched a cartoon. Have you guys ever watched a cartoon called Oh, seriously? We're just going to be distracted this morning. I know pep rallies happening. Pull that stool down. I don't care. I keep saying this. I don't care why anyone's asking anything. If we're not on task, it's the only thing I care about. I'm not trying to get anybody's business. I don't want to know what anybody's doing or talking about. But if you're talking, you're wrong. I mean, that's a pretty straightforward thing when you're getting information that you're going to need for your test. It's pretty straightforward. Now, I know that homecoming's coming up, and some of you are high steppers or cheerleaders or what have you. I know that you have a lot to do. You have coaches to meet with. You're very excited with your first high school. I hope it goes really well for you. Pep rally is really, really loud. I don't go to it. I've gone to 23 of them. That's enough. I'll be here in my room if anybody wants not to go. We sit here and we play chess. Some kids read, that kind of thing. It is fun, though. If you've never gone to a pep rally, you should go. I'm just warning you, it's really loud. My suggestion is to bring some kind of hearing protection. Listen, it's going to get something like probably close to 90 decibels in that gym, and it's going to go on for about an hour and a half. It could easily do damage to your hearing. And some of you really love music, and it's sad that the people that love music the most are the ones that end up losing the quality and the ability to hear the music when they're older, just because they make really poor decisions when they're young. So think about it. When you're going to concerts, I'm going to tell you right now, 90% of the people on stage have hearing protection. They have earpieces in their ear that stop it from being that loud. Yet you who pay for the tickets go to the concert and don't put in ear protection. That doesn't make sense to me. The millionaires know it hurts their ears. They wear hearing protection. You're talking an hour or 2 hours. At that decibel, you're going to lose hearing. How much? It adds up. All right. So it's insidious. Do you know this word, insidious? You've heard of it because there's at least one scary movie called Insidious. Insidious is something that's evil, but it works slowly. It's not as insidious is something that's bad that happens slowly over time. It creeps into you, and losing your hearing is, gaining weight is insidious. It just takes a little bit of extra calories every day to gain a lot of weight. Losing hearing is insidious. You can go deaf by the time you're my age. My wife needs serious hearing aids. She's yet to go to the doctor, but she has hearing problems. She's only 40 something. I forget how old she is. Whatever, what's 1979 to now, whatever that is. Huh? I can't hear you.
How far apart are y'all?
12 years. Oh yeah, 57 minus 12, whatever that is. So the bottom line is, man, you guys focus on the really wrong things. So the real problem here is that you won't notice anything different in the short term. You'll hear ringing in your ear. If you ever heard ringing, you've just gotten deaf. You've just gotten a little deafer. You lost hearing. When you hear ringing, it's called tinnitus. Unless you have some kind of infection, you just lost hearing. You just lose a little bit every time it happens, and before you know it, you're my wife's age. Yeah, what? Man, that music used to be so good. Now it's kind of something's missing. Yeah, because you don't hear it, but you don't know it. You ever hear those people driving down the street with their music real loud? A lot of them are doing it to show off. But a lot of them have it so high because they can't hear it if it's not that high. And those, unfortunately, those people that spend that $5,000, $10,000 on that sound system and they're blasting it down the street to show off, those poor guys putting all that money into that car, into that vehicle, they were not going to be able to hear the music after just a few years. They'll have to just keep cranking it up. It just boggles my mind. Hearing loss is permanent. We have no way of fixing it. All right, so that's my PSA for today. Let's move on. So the elements of life, yeah, hey, thank you. The elements of life in the old days of the Airbender, in the show The Airbender, you ever see it? You ever seen the Airbender? The cartoon or the movie? They talk about elements, and their elements are fire, earth, right? Air, and water. And then they have another one, I don't know. There's another one that Europeans called ether. Some people call I don't know how to spell it, but it's pronounced chi in Asia, in some Asian cultures. So there's these 5 elements that people used to think made things happen. And I think, I forget what the ancient Greeks used to call it, but some kind of third force, some kind of fifth element, sorry. Some kind of something that allowed things to move. The Greeks thought that rocks were alive. And they thought that rocks were alive because they saw rocks move. So if something's moving, it's alive. Correct? A rock's rolling downhill. It just means that there's all kinds of legends about golems. You've heard of golems? Right? Rocks that become alive and move, statues that get up and walk around. Yeah, they're called golems. Those are old stories. Because people used to think, in fact, there's a lot of people that still think that everything has spirit, everything has energy. Everything does have energy. We know it has energy. It's called kinetic energy today. That's what we call it. But the ancients used to have this kind of idea. And this was kind of ubiquitous. In other words, almost every culture thought about it like this. Different cultures might have focused on one thing or another, but, pretty much everybody experienced air, earth, fire, and water, right? I mean, that was everybody, every human experienced it. And then every human realized that something had to be moving it, right? Like something made that wood turn into fire. What is that thing? Like how do you get wood to turn into fire? I don't know. So people would think it's people used to think anyways, it was this fifth element, right? This thing. So moving forward through history, there are these people called alchemists. Have you ever heard of an alchemist? Here, some people have. No, some people haven't. So alchemists, they... all right, so their objective was to take lead and turn it into gold. Now, that's a good idea, right? I mean, you can get rich. You can be the richest guy in the world. Great. And then there's an old story of Midas, the guy with the golden touch, turned everything into gold. All right. So their objective was so they started to separate. They said, let's do it. So they started a society. They called themselves alchemists. And alchemists were everywhere. I mean, everywhere. They were in the Middle East. They were in Asia. They were in Europe. They were all over at least the northern hemisphere. I'm not sure about Africa, but I'm sure in northern Africa, in Egypt, and in probably northern Africa for sure. They were out for a search. It was a mission. It was a true society. And they started to separate things. Their big thing was, let's separate. So separate, whatever. Spelling is difficult, especially when you're talking and writing. It's not easy, and anybody thinks it is, they can come up here and try. So just let you all know, it's not easy to talk about one thing and write something down and be thinking about the next thing you're going to say. So separate everything. And they wanted to separate everything. So they started to melt. They took ore, that's minerals, a rock, and they melted it. They melted it.
Can I say one?
Ore, O-R-E.
Or?
O-R-E, ore. What? No, I'm saying ore, like a rock with different minerals in it. And, maybe there's some copper in it or something like that. You want to melt it. Why do you want to melt the rock? Why do we melt rocks? You want to do what with the minerals? What do we do with all those minerals? We take rocks. Think. What are you going to do? Why would you melt rock? Cement's no. I'll talk to you about cement, I guess. I have to talk to you about cement because that's a bad idea that you think that cement is not melted rock. Cement is not melted rock. So hold on. We're jumping all over the place. Why would you melt rock? Why would anyone want to melt rock? Right. Well, yeah, they want to get something. Look, you got a rock. Why you melt it? You have some ideas. You have brains. Let's start thinking. Well, okay. Yeah, what?
Bless you.
To get another rock? Okay, so you melt it. You've never...
Nah.
What are you nodding about? So you melt it, and what you do, and what your ancestors did, all our ancestors did, they melted rock so that they can separate the minerals. Because what would happen is that the minerals that were least dense would be on top as a liquid, only as a liquid. The mixed up solid, if we melt it, then as a liquid, what would happen is we would get these layers of minerals. These are liquid layers. Are we getting this? Is that making sense to you? Yes or no? Yeah. And then, because we have these liquid layers of rock, and we let them settle, we can scoop out, as a liquid, we could scoop out the green mineral and put in its own container. And then we can scoop out the gray mineral. I'm not even going to get into what each one could be, but the least dense is on top. Do you remember that from middle school, that less dense things float?
I didn't learn science.
Well, did you learn that from Dora the Explorer?
I'm so serious.
I'm serious too. Did you know, let me rephrase that. Did you know less dense things float? It's okay. I'm not judging anyone. I'm not saying you're wrong. I'm just saying, bottom line, I'm telling you now, less dense things float. Less dense things float. Write it down. Less dense materials float, okay? As long as they're liquids. Obviously, a solid, you couldn't do this if it were a solid form, correct? Now, do y'all remember the rock cycle?
Yeah.
You got to remember the rock cycle. They had to cover the rock cycle in elementary school. It's the easiest thing there is. All right, some don't remember. Okay, well, let's talk about the rock cycle. So in the rock cycle, yeah, magma, that's correct. Yeah. Hey, I'm not judging, because I'm not one to judge. I'm just saying, I'm not going to judge someone's mistakes, because, we all make mistakes. So some of us don't think we make mistakes. I'm just saying, but, I know I make mistakes. So anyways, so in the rock cycle, the question is, how do we get different rocks? And in the earth, you have this core, right? The core. And then you have another layer, and another layer. And there's layers of the earth. There's an inner core, outer core. Mantle. And like something like the crust. That's it. That's where we want to get to. I think it's called a stenosphere, I think, or something like that. I can't remember. I'd have to look it up. My point is that here in the crust, we live here on the surface. Trying to get to a brown. I don't know. Why don't they just give us brown? I don't know why. It's red. Brown is a form of red, orange. You would think, right? There's nothing.
You skip past it. You skip past it like 3 times. A brown.
I don't know, man. I don't see a brown.
Can somebody help him?
If you can find a brown, go ahead.
It's right.
Nah, if she finds a brown.
Oh, I hate you. Thank you. No, I'm just joking. Thank you. So anyways, so all the land that you're used to seeing, oh my gosh, now it just disappeared. Great. But at least I know what she did. I saw what she did. She took this down like this.
No, you still wrong. You're not there yet.
All right, just chill out.
You just passed it.
All right, that's close enough, all right?
No, it's not.
I don't care. That's what it's going to be. So everything, all the stuff that you know, all the stuff that you know is sitting here on top of this liquid. This is liquid rock. Liquidish. Ish. Do you know what ish? Yeah. Okay, so liquidish. So liquidish rock. And that includes, by the way, all the oceans. You know how deep the oceans are? The oceans are here. Everything. The highest mountain is here. That's it. That's the highest mountain. And our cities are here. These tiny little dots are our cities and our roads. That's how big the earth is. When we're talking about deep, that what we see, everything we see is here on the surface of the earth. Imagine an apple, right? And the peel, the red peel on the apple, that's everything you know. Everything else is inside the apple. So the earth, if the earth is the apple, everything you know is on the thinnest layer on its surface. It's crazy, isn't it? That most of our planet is underneath us, and we don't know what it looks like, and it's full of this liquidish, because partly liquid, partly solid, mixing, churning, hot magma. We call it magma. So this is magma. Now, magma is just a mix of all these minerals, okay? If that magma comes out, and why is it solid? Why are we able to walk on solid earth? Why is the bottom of the ocean solid? What is rock? It's minerals that have cooled down. That's what solid means. It's a liquid that's cooled down. Just like water, when it cools down, it turns into water. When it cools down, it turns into ice, solid water. Yes, you may go. So water that cools down turns into a solid. Do you remember that? That you have a liquid. A liquid is very, let me redraw this. If we were to take the little particles, we haven't talked about that. I guess we're going to have to talk about it tomorrow. The particles that are far apart, far-ish apart, we're going to call it a liquid. If the particles are really far apart, if the particles are really, really, really far apart, we're going to call it a gas. And if the liquids are really close together, we're going to call it a solid. Okay? And what's the difference here is that this is cold, this is hot, and this is something in the middle. This is something in the middle. Did I give you a temperature here? No, I didn't, because everything has a different temperature where it turns from solid to liquid to gas. So now let me go ahead and identify this. What is this when it goes from liquid to gas? What do we call that? When it goes from liquid to gas. That's right, good. Evaporation point. When it's evaporating really quickly, we call it boiling point. All right, it's another word for it is boiling point, but that's only when it's happening. Boiling is when the evaporation is happening very quickly. When the liquid goes to solid, what do we call that? Freezing, that's right. Now, this is freezing. Now, evaporation means you're going from a liquid to a gas. Okay? Yes? What happens when you go from a gas to a liquid? At the same temperature, we can go from a gas to a liquid. What do we call that? Condensation. Condensation point and boiling point or evaporation point are the same temperature. The only difference in the word is what direction is it going. Is that clear to everybody? So if you're evaporating, you're going from liquid to gas. If you go to condensation, you're going from gas to liquid. So on a summer day, you have your iced tea and you're sitting there on a hot, humid day, and on the outside of the glass you get little beads of water. Have you ever had that happen to you? You're drinking your tea or your water, and there's little ice cubes in it. It's really cold. On the outside of the glass, you get these little beads of water forming. Your glass at the bottom. Why do you use a coaster? Why do you use a coaster on your table? Because what happens at the bottom of your glass? It forms a ring of what? Of water. Where's that water coming from? Is the glass leaking? It's coming from the air. The hot, humid water touches the cold glass, and what happens? The gas turns into a liquid. It condensates. Those of you that wear glasses know this very well, don't you? Don't we? Every time we go from a hot, humid area into a cold air, what happens to our glasses? They get foggy. That's condensation. Anytime you go from a cold area outside, the hot, humid air, the water in that air turns into liquid on your glasses. Condensation. This all should be reviewed, and if it's not, that's okay. Then you have to learn it. Okay, you have to know this. This is something you need to know. Evaporation points from liquid to gas, condensation points from gas to liquid. I just lost my pencil. Where'd it go? Thank you. When you're going from liquid to solid, we call it freezing. At what temperature does that happen for water? Say what? What temperature does water freeze? 0 is correct. 0 is correct. So the 0 degrees is freezing point for water. It's not for there are other things that have. For fresh water. Salt water has a lower freezing point, which is why you put salt on ice, because it turns into salt water, and that has a lower freezing point, so it melts the ice. So what is melting? What is melting? If freezing is going from liquid to solid, what is it? What is melting? That's right, solid liquid. At the same temperature. At what temperature did water freeze? At what temperature did water freeze? You just said it, guys. Come on. 0 degrees. So water freezes at 0 degrees. At what temperature does it melt? At what temperature does ice melt? 0 degrees. Same temperature. The temperature is the same. The melting happens at the same temperature between. So freezing point, melting point are not a temperature difference. It's not a temperature difference. It's what direction is it going? Is that clear? Whoever said no is thinking, and that's good. It shouldn't be clear. So how is that possible? Why is something, how is it the same temperature, something could melt, and then something could freeze? How do you know if it's freezing or it's melting? Well, how you know is easy, right? If it's getting colder, what's it doing? Temperature's going down, so what's happening? It's freezing. If it's getting warmer, what's going to happen? It's going to melt. And if it's getting warmer still, it's going to evaporate. And if it's cooling, it's going to condensate and then freeze. So yeah, it's all about whether it's getting hotter or colder. That's the only thing that tells you the difference. And then every material has different. We can thank the alchemists for coming up with this, because it's their greed and their focus on trying to find out how to separate these rocks that allowed them to really get to a lot of this. Also, war. People wanted to make really strong metal swords and armor, so they spent a lot of energy and money try to isolate and make tough metals. Human history has somewhat been defined by the Bronze Age, which is a metal, the Iron Age, which is a metal. Iron is stronger than the bronze, and every time a new metal was discovered, new weapons were made, and that led to success. If your armor was made of bronze and somebody had an iron sword, you're in trouble, because their iron sword's going through the bronze. So anyways, when we're talking about this really basic idea, I mean basic meaning fundamental. This is fundamental. Like I know that this is who thinks that this is something new or something they didn't remember from middle school? Be honest, it's okay. All right, so it's something we gotta learn, guys. It's okay we didn't learn it or we don't remember it, but we gotta learn it. So freeze it. So you got these points. I'm gonna use orange, I guess, because I'm not trying to make it brown. These 2 points, these 2 temperatures, they're where things change from phase. We call this phase change. Have you heard of that before? Phase change. And phase is the state of matter. Matter is anything that takes up space and has mass. There's 2 basic things in the universe, 2 basic divisions of existence. There's matter on one side, and what's on the other? There's matter on one side, and what's on the other? Matter has mass. Mass is a measurement of how much matter you have. Volume is a measurement of how much you have as well. What is the other stuff that's not matter? Stuff that's not matter. Energy. Einstein, with his famous equation E equals mc squared, said that energy and matter are equal. They're the same. You can change energy into matter. You can change matter into energy. They can be changed. So you can take this stuff. And remember, the ancients thought that there were these elements, and these elements' movement was from this other element that they couldn't identify. Today, we call that thing energy. And energy is what allows things to move. There's a lot of different kinds of energy. You've heard of some of them. For God's sakes, I know you've heard of some of them. You've heard of kinetic energy. You've heard of potential energy. That's an easy one, right? Yes? Matter is and the difference between energy and matter is that matter has mass. Light, for instance, is energy. Light, sound is energy. So when we talk about, well, sound is a mixture of energy and matter, but light is pure energy. It has no mass. Does that make sense? It doesn't take up space. X-rays, radio waves, microwaves, they're all forms of light. Did you know that? Microwaves are a form of light. Gamma rays, X-rays are all light. They're just not visible to the human eye. What are the colors of light that are visible to the human eye? Since we had our colorist up here helping me make brown, what are the colors of the taking a look at one form of energy? There's only one form of energy is light. Light is a form of energy, and there's all kinds. There's visible light, and then there's light, and then there's light that's bigger and light that's smaller. Very small light. What are the colors of the rainbow?
Red, orange, yellow, green, blue, purple.
Roy G. Biv. Red, orange, yellow, green, blue, indigo, and violet. They're in this order. When you look at the rainbow, they're in this order. If you ever see them, red, orange, yellow, green, blue, indigo, and violet. Red, orange, yellow, green, blue, indigo, and violet. Now that's our alarm. We got 2 minutes left. I got to take attendance. So it looks like from this discussion we have a lot of basic physical science to cover. All right, so we're going to have to do that this week. Okay? Hold on. Let's take a look at what we're going to try to focus on. Before we go, we want to summarize our notes because somebody in this room wants to get a good grade on their binder, I'm assuming. So they're going to have summaries and they're going to have key ideas. What were the key ideas here? Let's start from the beginning. That there are these things called elements, that the alchemists first tried to discover what these elements were so that they could turn lead into gold. And in order to do that, they had to separate rock. And to do that, they had to melt it. We learned one really basic fundamental property of matter, that less dense things float. This is incredibly important. We'll learn later that that's one of the reasons life exists on planet Earth, is less dense things float. Very important idea. If they're liquids, obviously, or solids, if the less dense thing will float on the more dense thing. We learned that there's these different states of matter. There's gas, liquid, and solid. There's more, by the way, but there's these three basic ones. That to change from liquid to gas to water, there's these points: freezing point, evaporation point, condensation point, melting point. Evaporation and condensation happens at the same temperature. Freezing and melting happens at the same temperature. You should make sure you understand all that. I'll try to give you a quiz on Wednesday for it. So there should be index cards being made. There should be practice going into learning this. Phase change means a state of matter. Phase change is this changing of the state of matter, solid, liquid, and gas. Matter is anything that takes up space and has mass. Matter can be changed into energy, and one form of energy is light, and visible light can be broken down into Roy G. Biv. That's a lot, but you need to know all that by Wednesday. I don't know why anyone's out of their chair. Still got a minute.